Let's solve some problems. Let's do the first one. Within that, the first one, 91 is congruent to 1 mod 9. We have to show that the statement is true. So let's proceed. 91 minus 1 is divisible by 9. So 9 divides 91 minus 1. 9 divides 90, which is true. Okay. B. 23 times 215 is congruent to 3 mod 7. Okay. Now in this case, what we'll do is we'll do, take this separately and we'll find the mod. So 23 is equal to, take this 7 and multiply it with a number which takes it closest to the 23. So 7, 3 is a 21 and remainder is 2. Okay. Similarly, 215 is equal to 7 times 7 3 is 21 and 5 is the remainder. So what this implies is 2 is congruent to 23 mod 7. Similarly, 5 is congruent to 215 mod 7. So now what we'll do is we will write 23 times 215 is congruent to 2 times 5 mod 7, which means it is congruent to 10 mod 7, which implies that it is congruent to 10 mod 7 can be written as 10 divided by 7, remainder is 3, right? So 3 mod 7, which is the right hand side. Okay, let's do the third one. 7 times 6 times 5 times 4 is congruent to 0 mod 6. Now here we can immediately make out that 6 divides 7 times 6 times 5 times 4 minus 0. This we can ignore. And this is true because 6 is there here. Next one. 109 times 431 is congruent to 9 mod 11. Okay, just like before, let's write 109 as divided by 11. So 11 nines, 99. 109 minus 99 is 10. So remainder is 10. 431 can be written as 11 times 11 3 is 33 and 9, and the remainder is 2, so which means this implies that 109 is congruent to 10 mod 11. This implies 431 is congruent to 2 mod 11. So which means 109 times 431 is congruent to 10 times 2 mod 11, which means it is congruent to 20 mod 11, which means it is congruent to 11 ones 11, remainder is 9. So 9 mod 11, which is the right hand side. Now let's do a slightly more challenging one. Okay, let's do the second one. 52x is congruent to 28 mod 20. Now here what we have to do is we have to figure out what is the value of x. So we have to solve. In such a situation, first we have to figure out whether there are any solutions for this. So for that, let's figure out the GCD of 52 and 20. So this is 4. So 52, 20, 2 2s, 2 6, 2 10s, 2 1s, 2 3s, 2 5s. So 4 is the GCD and 4 divides 28. So therefore there exists a solution, and not only a solution, 4 solutions. So how do we go about solving this? 52x is congruent to 28 mod 20. Here all of them are divisible by 2. So 2 2s are 4, 2 6 are 12 is congruent to 2 1s 2 4s mod 2 10s. Again it is divisible by 2. So 2 13s, 2 7s mod 5. Now 13x can be written as 3x plus 10x is congruent to 7 mod 5. But 10 is congruent to 0 mod 5. So therefore, we can strike this out. We are left with 3x is congruent to 7 mod 5. Now, somehow we have to make this 3 disappear. So what do? We can say 3x is congruent to 7 mod 5 can be written as 2 mod 5. It's still not divisible. So let's write it as is congruent to 12 mod 5. So basically here what did we do? We subtracted 5 and then we added 2 times 5. Okay, so now this and this gets cancelled, 4. So x is congruent to 4 mod 5. So therefore 4 is the least positive integer in the residue class, that is 4 belongs to I5. Now remember, there are how many solutions? There are supposed to be 4 solutions, which means solutions are, so what we can do is B is equal to 5t plus R remainder. So here it is supposed to be B is equal to 5 times t plus 4, and this t value goes from 0 1 2 3. Okay, so let's do the substitutions and figure out the solutions. So B is equal to 5 times 0 plus 4. Similarly, 5 times 1 plus 4, 5 times 2 plus 4, 5 times 3 plus 4. So this gives us 4, which we have already found. This is 9, this is 14, this is 19. So therefore, B is equal to 4, 9, 14, 19, or B belongs to, much more appropriate. Okay, let's do the next one. 42x is congruent to 12 mod 90. Okay, now GCD of 42 and 90 is equal to 6, and 6 divides 12. So therefore there exists x with 6 solutions. Okay, so let's see how to figure out that. Now 42x is congruent to 12 mod 90 can be written as 6 7s are 42, 6 2s 12 mod 6 1 6 6 5 30 mod 50. And now what we'll do is we will have to get rid of this 7. Now how do we get rid of this 7 mods 15? We have to take the inverse of this, because when we bring it to this side it should get divided by. So it is like your normal fractional multiplication. When you have to divide it by a fraction, you take the reciprocal of it, or multiplicative inverse. So similarly, we have to figure out the multiplicative inverse of this. So for this, let's figure out 1 mod 15. Now how do we figure out 1 mod 15? Now here remember, remainder is 1. So that means it is going to start with 16. Right? 16 mod 15 is 1. And now we just keep adding 15 to it. So 16 plus 15 is 31, plus 15 is 46, and so on. Similarly, let's go backwards. So 16, we are going backwards. So minus 15 is minus 14, minus 29, minus 44, and so on. Okay. Now what we'll do is, we want a number which is divisible by 7, right? Which is nearest to 0. So if you notice, this is not divisible by 7, this is not divisible by 7, this is not divisible by 7, this is divisible by 7, right? So since this is divisible by 7, what we have to do is, we have to convert this 7 into minus 14. So how do we do that? What we do is, we actually don't do that, we just write 7 inverse. X is congruent to 2 times. Now to get this minus 14, we have to multiply it with what? Minus 2. So we multiply it by minus 2 mod 50. Because if you write minus 2 here also, what will happen? You will end up with minus 40. And then you will do cancellations. You will end up where you were. So here what we have done is, we have figured out the multiplicative inverse. So which means this and this will get cancelled out, and you are left with X is congruent to minus 4 mod 15. But your solution should always be a positive integer. So what do? We add 15 to it. So adding 15 to it, we'll get 11 mod 15. But now there are supposed to be 6 solutions. So again, we say B is equal to 15 times T plus 11. And T will go now from 0, 1, 2, 3, 4, 5. So let's figure out. 15 times 0 plus 11. 15 times 1 plus 11. 15 times 2 plus 11. 15 times 3 plus 11. 15 plus 4 plus 11. And 15 times 5 plus 11. This would be 11. This would be 26. This would be 41. This would be 56. This would be 71. And this would be 86. So these are the solutions or values of for which the statement is. Okay, let's do the next one. Fourth one. 25x is congruent to 15 mod 9. 29. Okay. Now what we'll do is, we'll simplify this. So we'll divide it by 5. So 5 5s, 5 3s, mod 29. And the GCD of 5 and 3 is equal to 1. And 1 divides 3. So therefore, there exists only one solution, since the GCD is 1. Okay. So now 5x is congruent to 3 mod 29. So we start with what? We start with 3 and keep adding 29 to it. So 29 plus 3 is 32, plus 29 is 61, and so on it will go. If we go backwards, 3 minus 29 is minus 26. Minus 29 is minus 55, minus 84, and so on it will go. Now, which one of these is divisible by 5? So none of these, only this. So which means we can write this as 5x is congruent to minus 55 mod 29, and 5 and 55 get cancelled, and we are left with x is congruent to minus 11 mod 29. But now we need a positive integer. So add 29 to it. So 29 minus 11 will be 18 mod 29. Okay, let's do the fifth one. 9x is congruent to 42 mod 6, GCD of 9 and 6 is equal to 3, and 3 divides 42. So therefore there exists 3 solutions. This shows that solutions exist, and this tells you that there are 3 solutions. Okay, now 9x is congruent to 42 mod 6. All of them can be divided by 3. So 3 3s, 3 1s, 3 4s, 3 2s. So that means 3x is congruent to 14 mod 2. Okay, and we start with 14 and we keep adding 2. So 14, 16, 18 and so on. And when we go backwards, we get 12, 10, 8, 6, 4, 2, 0 and so on. Which one of these is divisible by 3? So you might think, okay, we are starting with 14, so 12 is divisible by 3. But you should go as close to 0 as possible. So if you notice, 3 is divisible by 3, 6 is divisible by 3, but 0 is also divisible by 3. And 0 is a nice number because it leads to a lot of cancellations. Okay, so which means we can take 0. Okay, so which means we can write this statement now as 3x is congruent to 0 mod 2. Now let's divide both these by 3. So this becomes 3 by 3x becomes 1x, 0 by 3 is 0 mod 2. So that means that the solution is 0. One of the solutions is 0, and it's going to be the smallest least integer solution. So which means solutions are 2t plus 0 remainder. Okay, b is equal to, so now b is equal to 2 times 0, because how many solutions are supposed to be there? 3. So this will go 2 times 0 plus 0, 2 times 1 plus 0, and 2 times 2 plus 0. That means this will be 0, this will be 2, this will be 4. So therefore x belongs to 0, 2 and k. Let's do the next one. Sixth one. 13x is congruent to 9 mod 25. GCD of 13 and 25 is equal to 1. That means solution exists, and there is going to be only one solution, especially since 1 divides 9. So this implies there exists one solution. So let's figure out that solution. Okay, so 13x is congruent to 9 mod 25, and what we are going to do now is we are going to start with 9 and we'll keep adding 25 to it. So 25 plus 9, 34, 59, 84, 109, 134, 159, 184, 209 and 234. And if we go backwards, we will get minus 16, minus 41, minus 66, minus 91 and so on. Now you have to check which of these is divisible by 13. So which one is divisible by 13? This is divisible by 13 and this is divisible by 30. Okay, but which is nearer to 0? Minus 91 is nearer to 0. You can take either one of them, right? Either way you will get the same solution, but calculations become easier. So which means what? I can write it as 13x. 13x is congruent to minus 91 mod 25. Okay, so which means now we can do these cancellations. Minus 7. So x becomes congruent to minus 7 mod 25. Again, we require a positive integer. So minus 7 plus 25 will give us 18 mod 25. And that is the solution. Okay, let's do the next one. Seventh one. Okay, 259x is congruent to 5 mod 11. Now, GCD of 259 and 11 is equal to 1, and 1 divides 5. So therefore, one solution. Okay, now we can simplify this. So let's write 259x is congruent to 5 mod 11. Now this 259 is congruent to 6 mod 11 divided by 11. What will you get? 11 2's 22, 3 39, 11 3's 33, and the remainder is 6. So 11 times 23 plus 6. So 6 mod 11. So we can write this as 6x is congruent to 5 mod 11. Now comes the tricky part. You start with 5 and start writing, adding 11 to it. So 5 plus 11 is 16, 27, 38, 49, 60, 71, 82, 93, 104, 115, 121, and 126, and so on. Similarly, backwards if we go, minus 6, minus 17, minus 28, minus 39, minus 50, and it will keep going, minus 61 and minus 72. This is minus 61. Okay, and it will go on. Now here, which one of these is divisible by 7? Sorry, divisible by 6. So we started with 5. So 6, no, 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 no. 6, 10, 60, right? So 60 is divisible by 6. And on this side, 72. So we can take either one of these and solve it. Let's do both. Right? Let's do both and see whether it actually gives you the same solution or not. 6x is congruent to 5 mod 11 using minus 72. We can write it as 6x is congruent to minus 72 mod 11. So 616, 6 12. So x is congruent to minus 12 mod 11. We want an integer, so we add 11 to it. When we add 11 to it, what do we get? Minus 1, right? So minus 1 mod 11. We still don't have a positive. So we add again one more 11. We get what? 10 mod 11. Okay, now let's do it with 60. So 6x is congruent to 60 mod 11. So 6 tens 60. So x is congruent to 10 mod 11. Either way, you will get the same solution. And there's supposed to be only one solution. So that's it. You need to practice a lot. That's it for now. Bye.